A very warm good afternoon everyone. My name is Anjali Paul and I'm a student of Environment Science. My roll number is CUHPRE24ENV01. So my topic for today is latitudinal and seasonal variation of insolation. First of all, I would like to make you guys familiar with the term insolation. What does it actually mean? Insolation is basically the total amount of sun heat or the solar energy received by the earth or any other planet. So, Earth intercepts only 1 in 2 billion parts of the solar radiation. This intercepted radiation is called as insolation. When we talk about its definition, proportion of solar energy received or intercepted by the Earth is known as insolation. Now, I would like to tell you a fact that some heat within the core and the mantle is transferred to the surface and ocean bottoms through volcanoes, springs and geysers, but this heat received at the surface from the interior of Earth is negligible. It is totally negligible compared to the one received from the sun. What I mean to say is that the insolation received by the sun is much more in proportion than the heat energy received from the bottom of the Earth. Earth receives sun's radiation in the form of short waves, and when the heat gets reflected back from the Earth, it is in the form of long wave radiations. When we talk about the short waves, it is basically like visible light and the ultraviolet radiations. Plus, when we talk about the long wave radiations, they are basically infrared radiations. Now, I would like to tell you that the shape of the Earth is neither round neither oval. It is known as geoid, and the location of the Earth on the Earth can be mentioned in the terms of latitude and longitude. I would like to tell you, now I'll be discussing the topics, and one of them is latitude and a longitude. When we talk about latitude, we talk about the horizontal lines, and when we talk about the longitude, these are the lines in longitude. So when we talk about the latitude, these lines are actually equidistant from one another. But when we talk about the longitude, these lines are not at equidistant from each other. When talking about latitude, it divides the Earth into north and the south part, and when we talk about the longitude, it divides the Earth into east and the west parts. So now, when we talk about latitude, the symbol that signifies latitude is phi, and these are some standard latitude values. Like for equator, it is 0 degree. For Tropic of Cancer, it is 23.5 degree north. For Tropic of Cancer, it is 23.5 degree south. Arctic Circle, it is 66.5 degree north. Antarctic Circle, it is 66.5 degree south. North Pole is on 90 degree north, and the South Pole is on 90 degree south. Now talking about longitude. The longitude divides the Earth into east and west position, that I have already told you. And also, when we talk about the longitude, it is denoted by a symbol lambda. When we talk about the longitudes, these are not on equidistance, like it is totally opposite to latitudes. So now I will be discussing about the ways of transfer of heat energy. These are the three terms: radiation, conduction and convection. So first of all, I would like to tell you about the term conduction. What does conduction actually mean? Heat transfer through the matter by molecular activity. Heat transfer in iron and other metals is by conduction. When we talk about the term conduction, it is basically when two mediums comes in contact. The transfer of heat is known as conduction. But when we talk about convection, it basically happens because of the movement of molecules. And these molecules, it basically the convection part takes in fluids, that is like in gases and in liquids. When we talk about radiation, this heat transfer is without actual contact or the movement of a body. For example, I would like to tell you that like conduction, if a human touch, see I can explain it from this, like when we come in contact with the handle of the container, this is conduction, like we came in contact. When we talk about convection, heat comes from the fire and the water molecules. It is basically fluids and in liquids. So this is convection. And we talk about radiation, the fire makes warmth around the place wherever it is being lightened. So this is known as radiation. So these are the three basic things which determines the transfer of heat energy. Now I would be discussing about the distribution of temperature. It is basically based on two factors, that is horizontal distribution and vertical distribution. So these are the major factors responsible for the uneven horizontal distribution of temperatures. These factors are basically, the number one is solar activity or the sunspot, perihelion or the aphelion, the latitudinal variation, wind and ocean currents, altitude, cloud cover, land and sea contrast, aspect, topography, local effects like soil, vegetation, etc. Now I'll be discussing them one by one. First of all is solar activity and sunspots. The main change in the sun is an 11-year solar cycle. Now when we talk about the sunspot, you must have not heard about the term sunspots. It is basically like the most hottest part of the sun. And when we see like in a cycle of this solar cycle, we see sometimes that these sunspots are seen. They influence the temperature in a positive way, like they increase the temperature to a higher value. The powerful magnetic fields in the vicinity of sunspots produce active regions on the sun, which result in disturbances such as solar flares and coronal mass. At the peak of the cycle, about 0.1% more solar energy reaches the Earth, which can increase the global average temperature by 0.05 degree to 0.1 degree Celsius. What I mean to say is like these sunspots, how they influence the temperature. They are capable of increasing the temperature by 0.05 degree or 0.1 degree Celsius in a rotation. Now when we talk about perihelion and aphelion, like how I have learned is from the term perihelion, what we mean to say is pass, and aphelion we can say ki dur. When we talk about perihelion, it is during the revolution around the sun, Earth is farthest from the sun on 4th of July, and this is called as aphelion. And perihelion is when the Earth is closest to the sun. पास जितनी वो पास है उसको हम बोलते हैं पास से पेरिहीलियन और पास से दूर से एपिहीलियन. So this is on 3rd of January. Now talking about latitudinal variations. Latitudinal is the distance measured in degrees to north and south of the equator. The further away of location is from equator, the smaller is the angle at which the sun strikes the earth. Now I will be discussing here. When we see this earth, like when the solar radiations are parallel, we receive the highest amount of solar energy here, and here we find that it is like the hottest climate we see here. And as the angle of incoming solar light increases, what happens is here the sunlight gets spreads away, it gets spreaded, and the amount of heat here received is little less than the one received on the equator. Now, when we talk about the altitude is the height of the point above the sea level. As we know that the temperature, like when we start going away from the earth, the temperature goes on decreasing, and this is called as lapse rate. Temperature decreases by 6.5 degrees Celsius for every increase in 100 meter. हर एक 1000 मीटर पे टेम्परेचर जो होता है वो 6.5 डिग्री सेल्सियस से वो कम होता जाता है. The air at the high altitudes is thin. At higher altitudes, the air is made up of smaller concentration of gas, dust and water vapors than the dense air at the sea level. बोलने का मतलब ये है कि जो हायर ऑल्टीट्यूड्स पे होते हैं वहाँ पे एयर जो होती है वो कम कॉन्सेंट्रेशन में होती है. वहाँ की जो गैसेस होती हैं, जो वाटर वेपर्स और जो डस्ट होते हैं वो इतना डेंस नहीं होता है. थिन एयर इज अनेबल टू एब्जॉर्ब हीट. और उस लाइक आई टोल्ड कि जितने हम ऊपर जाते जाएंगे वहाँ की जो एयर होगी वो उतनी ही थिन होगी, कम डेंस होगी. तो जो कम डेंस एयर होती है, जो थिन एयर होती है, इट इज़ नॉट कैपेबल ऑफ एब्जॉर्बिंग हीट एज मच एज द डेंसर वंस. दस इसलिए हम ये बोलते हैं कि जैसे जैसे हम ज़मीन से ऊपर जाते जाते हैं वैसे वैसे जो टेम्परेचर होता है वो डिक्रीज होता जाता है. Now talking about cloud cover. So here I will be discussing about the two aspects. One is tropical and one is the temperate. When talking about the tropical areas which has dense cloud cover due to high humidity in air experience a small difference in day and night temperature. जब हम tropical की बात करते हैं तो वहाँ पे हम ये पाया जाता है कि वहाँ के जो क्लाउड कवर होते हैं वो बहुत डेंस होते हैं, और उसकी वजह से क्या होता है कि उसकी जो ह्यूमिडिटी होती है वो भी बहुत ज़्यादा होती है, और उन एरियाज़ में जो होता है बहुत कम एक डिफरेंस देखने को, टेम्परेचर वेरिएशन जो है बहुत कम देखने को मिलती है एज़ कम्पेयर टू डे और नाइट कंपेरिजन में. लेकिन जब हम बात टेम्परेट एरियाज़ की करते हैं वहाँ पर हमें लेस क्लाउड कवर मिलता है, और उस वजह से वहाँ पर कम ह्यूमिडिटी पाई जाती है, जिसकी वजह से जो टेम्परेचर की वेरिएशन डे और नाइट में होती है वो ज़्यादा होती है या ज़्यादा हमें देखने को मिलती है. नाउ आई विल बी डिस्कसिंग दिस इन डिटेल. ड्यूरिंग द डे tropical area with more cloud cover, clouds absorb incoming solar radiations from the sun. Clouds also reflect part of the incoming solar radiation back into the outer space. Thus, lesser solar radiation reaches the Earth's surface and the heating effect is less intense, lowering daytime temperatures. However, during the day, in temperate places with less cloud cover, the lack of cloud cover allows large amount of solar radiations to reach the Earth's surface in day, causing the temperature of the ground to rise quickly, raising daytime temperatures. और जब हम रात की बात करते हैं तो at night in places with more cloud cover, clouds reflect heat radiated by the ground back to the Earth's surface, preventing heat from escaping into outer space. This keeps the temperature of the ground high at night. At night, in places with few clouds, the lack of cloud cover allows heat from the Earth to escape into outer space easily, leading to a sharp drop in temperature of the ground, lowering night time of the temperature. Land and sea breeze contrast. Now I would like to tell you this is sea breeze and this is land breeze. When we talk about like how this occurs, I would like to give you explanation. When we compare land and the sea, what fact we find is कि जो पानी होता है वो हीट अप होने के लिए ज़्यादा समय लेता है, प्लस वो ठंडा होने के लिए भी उतना ही ज़्यादा समय लेता है एज कंपैरिजन टू द लैंड. जो लैंड होता है वो जल्दी तप जाता है और जल्दी वो अपना टेम्परेचर लूज भी कर देता है. उस वजह से हमें ये एक फिनोमिनन देखने को मिलता है जिसको हम सी ब्रीज और एक लैंड ब्रीज बोलते हैं. दिन के टाइम पे व्हाट वी फाइंड इज कि जो हमारा लैंड होता है वो ज़्यादा गर्म होता है, तो वहाँ की जो हवा है वो भी ऑटोमेटिकली गर्म हो जाएगी. तो वहाँ से जो हमारे वार्म एयर है वो सी की तरफ को ट्रेवल करनी शुरू हो जाती है. वहाँ से वो क्या होता है कि जैसे जैसे वार्म एयर लैंड से जाएगी वहाँ पे वो ठंडी होती जाएगी, ठंडी एंड देन ऑटोमेटिकली इट कम डाउन टू ओशंस. और जब ओशन से ठंडी हवा जो है वो हवा के साथ साथ ही वो ठंडी हवा जो है वो लैंड पे चली जाती है. इसको हम सी ब्रीज बोलते हैं. एंड दिस फिनोमिना यूजुअली टेक्स प्लेस इन डे टाइम. एंड व्हेन वी टॉक अबाउट नाइट, तो रात के समय में क्या होता है कि जो नदी है वो ज़्यादा टाइम लेती है मतलब अपनी हीट छोड़ने के लिए, तो मतलब पानी ज़्यादा देर तक गर्म रहता है. तो इसकी वजह से क्या होता है कि जो वार्म एयर होती है ओशंस की वो जाती है लैंड की तरफ और वहाँ से कूल डाउन होकर वो ट्रेवल कर जाती है ओशन की तरफ जो ठंडी हवा होती है. इसको हम बोलते हैं सी ब्रीज और land breeze. Now talking about winds and ocean currents. Major ocean currents are greatly influenced by the stresses exerted by the prevailing winds and Coriolis force. Now when we talk about the winds and oceanic currents, इनको सबसे ज़्यादा influence कौन करता है? इनको winds और जो Coriolis force है वो सबसे ज़्यादा influence करती है. The air circulation over the oceans in the middle latitudes is mainly anticyclone, more pronounced in the southern hemisphere than in other hemisphere. The oceanic circulation pattern also corresponds with the same. At higher altitudes पे क्या होता है? Where the wind flow is mostly cyclonic. Higher altitudes पे क्या होगा? जो wind flow है वो cyclonic होगा और जिसकी वजह से क्या है? The oceanic circulation flows with this pattern. In this region, the pronounced monsoonal flow, the monsoon winds influence the current movements. Due to the Coriolis force, जो warm currents होते हैं from the low latitudes, जो लो लैटिट्यूड है वहाँ पे हमारे को वार्म करंट्स देखने को मिलते हैं. वो टेंड करते हैं लाइक दे स्टार्ट मूविंग टुवर्ड्स द राइट इन द नॉर्थ हेमिस्फीयर एंड टुवर्ड्स द लेफ्ट इन द सदर्न हेमिस्फीयर. The oceanic circulation transports heat from one latitude belt to another belt. Like इसी oceanic circulation के साथ और इसी wind के साथ क्या होता है कि जो हमारी heat energy है वो flow करनी शुरू हो जाती है एक latitude belt से दूसरी belt को, and so on it passes to one another. The cold waters of the Arctic and Antarctic circles moves towards warmer water in tropical and equatorial regions, while the warm waters of the lower latitudes move towards pole sides. बोलने का मतलब ये है कि दिस इज आवर अर्थ, द आर्कटिक ओशंस एंड द एंटार्क्टिक सर्कल्स. यहाँ से जो ठंडी हवा है वो मूव करती है, ये ठंडा पानी है कोल्ड वाटर दैट स्टार्ट मूविंग टुवर्ड्स द इक्वेटर फ्रॉम बोथ द साइड्स, और जो इक्वेटर्स का गर्म पानी है इट स्टार्ट मूविंग टुवर्ड्स द पोल्स. सो दिस इज द ओशन करंट्स. Cold water currents is being addressed by these blue lines and the warmer air currents is being addressed by these red lines. So when we talk about the aspects हम ये समझते हैं कि जो माउंटेन है उसकी जो स्लोप है वो किस तरफ को है, लाइक कि सन से वो किस तरफ को फेस कर रही है. इट इज लाइक एस्पेक्ट रेफर्स टू द पोजीशन ऑफ माउंटेन स्लोप इन रिलेशन टू द डायरेक्शन ऑफ सन्स रेज. द इफेक्ट ऑफ एस्पेक्ट ऑन टेम्परेचर इज मोर मार्क्ड इन टेम्परेट लैटिट्यूड्स. जो अगर हम टेम्परेचर की बात करें तो एस्पेक्ट वहाँ पे रोल ज़्यादा प्ले करेगा जहाँ पे हमारे टेम्परेट लैटिट्यूड्स देखने को मिलते हैं। लेकिन जो ट्रॉपिकल लैटिट्यूड्स होते हैं वहाँ पे जो एंगल ऑफ मिड डे सन होता है वो हाई होता है। इसकी वजह से क्या है, द इफेक्ट ऑफ एस्पेक्ट ऑन टेम्परेचर इज लेस नोटिसेबल, वहाँ पे हमारे को कम ये देखने को मिलता है। इन द नॉर्दर्न हेमिस्फीयर द साउथ फेसिंग स्लोप्स आर वार्मर दैन द नॉर्थ फेसिंग स्लोप्स. This is because south facing slopes receive more direct solar energy and are protected from polar cold winds. The sun rays reach them at steeper angles, so the heat distributed over the small area. In southern hemisphere, the north facing slopes are warmer than the south facing slopes. This is because the north facing slopes receives more direct solar energy and are protected from solar cold winds, and sun's rays reach them at a steeper angle, so heat distributed over them is smaller. Length of the day. Temperature generally increase with the length of the day. जितने समय तक टेम्परेचर दिन ज़्यादा रहेगा उतने दिन तक क्या है कि जो टेम्परेचर है वो भी इंक्रीज होता रहेगा. So this is about my presentation. Thank you so much.